Okay. So now we should be seeing the problem that we were talking about. Yes?
There we go. Yes.
Cool. All right.
Yes.
Let's do this bad boy. Okay, so 8-ounce cup of coffee has 100 milligrams of caffeine. Function A of x equals to 100 times 0.88 to the x gives the amount of caffeine in milligrams in the body x hours after drinking a cup of coffee. Answer in complete sentences. Okay, so identify the vertical intercept of this function, write it as an ordered pair, and interpret its meaning in this sentence. Okay, so the vertical intercept means you just finished the 100 milligrams of coffee. So that's times 0.
Yeah.
So
yeah.
If x is equal to 0, then what you've got is a of 0, which is going to be equal to the initial amount, which is 100 milligrams. If you do the arithmetic on there, you'll see that it's a of 0 is equal to 100 times 0.88 to the 0, and anything raised to 0 power is 1, so you get back 100. So the order pair is 0 by 100. I'll let you write the sentence that says that's the initial amount of coffee, okay, or initial amount of caffeine.
Yep.
So how much caffeine is in the body 8 hours after drinking your cup of coffee, your 8-ounce cup? Well, that's going to be A of 8, right?
Yep.
Okay, so that's going to be equal to 100 times 0.88 to the 8th power. And we'll go get our handy dandy calculator here. Clear it all out, and so that's going to be 100 times 0.88 raised to the 8th. And so you have about basically 3.6 milligrams of...
Are you missing your 0 point? You got 0.
Oh, yeah, you're right. Thank you. So one more time. I thought that was seemed kind of strange. That was awfully quick to get rid of all that caffeine.
Your decimal point was in the wrong spot.
Yes. Well, dag nab, I tell you. Let's try that again. Garbage in, garbage out. Right. There we go.
There we go.
Yeah, 36 milligrams of caffeine left. Okay. So how long will it take the body to metabolize half of the caffeine from 1 cup of coffee? So in other words, how long until 50 milligrams are left? So half of it means, it's very similar to the question you were asking, okay, how do I solve an equation that looks like this? Not like that. Let's put a 0 where it belongs there. (0.88 to the x. And at this point in our class, we're going to have to solve that graphically. So a couple of different ways you can do it. If you want, you can simplify this a little bit by dividing both sides by 100, or you can just roll with it and put y1 is 50 and y2 is equal to 100 times 0.88x. So either way is fine. So let's go ahead and do it like this. Let's call y1 equal to 50 and y2 is equal to 100 times 0.88 to the x. So Charlotte, I can plug in my calculator and I can show you what it looks like on the phone. Do you want me to do that for you?
No, I think I got that. It's that the next one on D, to have it all go away.
Okay, cool. I just want to make sure you've got how that goes. All right. So,
yeah.
All right. So
see, did we need to draw a graph?
You should give me a sketch. Yeah.
Okay, I did.
Okay, cool. Because your sketch should look not quite unlike, but similar to this, where that's x. That's a of x, and you should have a declining exponential that looks something like this. And there is a point of intersection right there where that's 50 on the a-axis. And so what did that turn out to be? What was that, the x amount there?
5.42.
5.42?
Yeah.
Yeah.
Okay. So that says 5.42 hours to get you down to half of the caffeine that you originally ingested, okay? All right, so according to this model, how long will it take for all of the caffeine to leave the body? And what they're trying, there's really no work here. This is a thought experiment, or it's a thought problem. Because if we go back and look at just a of x for a moment, and don't look for any intersections. Here's a, here's x, right? You know, it starts up here at 100, and then it comes down like this. But what we also know is that the x-axis is playing starring role of what? It's a horizontal asymptote, isn't it, right?
Yeah.
So we'll abbreviate that as an HA, okay? Now, what is a horizontal asymptote? Well, what that means is the function is going to come down, and it's going to get as close as you ever want it to get to that horizontal asymptote, but it's never going to touch it,
Okay.
right? And so according to this model, which is where the model starts to fail with respect to reality, it's going to take an infinite amount of time. So it's going to take an infinite time, and that doesn't make any sense, does it? Right? Because eventually your body will get rid of it. So the model basically fails at that point. It just doesn't work anymore. It won't give you the time to completely excrete all of it out of your body. So you can, if you choose to, so you can set a limit at which you think 0 is equal to. So one way of thinking about this is you can say, well, you know what? I think when the amount, when A of x is equal to 0.00 when I round off, right? If I round it off to 2 places,
yeah,
then that's good enough, right? So if you want to go this far, you don't have to, but this is like just to kind of get the idea of it. We'll go into our y equals here. Let's go put in our model. So we got 100 times 0.88 raised to the x. And then let's go ahead and clear out this other crazy thing there. And let's just go into the table. And what I'm going to do is I'm going to put the table set. I'm going to go into the independent to be asked, so I don't have to scroll for 14 days on there. I'm going to go ahead and put in the amount I want to put in. And then go in second table. All right, so if we put in 10 hours, right? In 10 hours, you're going to have basically 27 milligrams left in your body, right? Okay, so let's see how many are in there in 24 hours. So after 24 hours, apparently there's still about 4 milligrams left in your body, right?
I've got over 36 hours, but it still kept going.
There you go. I was going to say, okay, I'm with you. So let's go 36. Okay, so if we go 36 hours, still got 1 milligram, right? Well, what if we go 2 days? Let's go 48. Maybe this stuff's like, THC and,
Well, that's what I was
you
wondering.
ate a cookie and 3 days later they still could find it in your blood, right? Or like poppy seeds in the bagels, So let's go 100 hours, right? Okay, now we're talking here. Okay, so after 100 hours, it's looking like, that's in scientific notation. Remember, there's 3 zeros in front of that.
Zeros before that.
Yeah, so after 100 hours, for all intents and purposes, it's gone. There's no detectable amount of caffeine left in you. You are pure. You have been cleansed at that point.
No more caffeine.
No more caffeine for you. So
I don't think I can go 100 hours without another.
Yeah, caffeine is a good thing. Okay, so does that make it more sense?
That makes more sense.
Okay, sweet. Okay, any other ones besides this, the caffeine problem? Anything from the practice problems?
That was
From chapter 6.
Chapter 6?
From
okay.
chapter 6, 6.1, the
6.1.
practice problems.
Okay.
Number 3.
Number 3. Hang on, I went a little too far. Sorry about that. I was down to the self-assessment. So 6.1. Problem number 3, Wakara, is that the one we're doing?
Yeah.
Okay. So write the expression function for each of the following. Is that the one?
Yes.
Okay, cool. All right. So that guy.
Yes.
All right, cool. All right, so what do we know? So we know that an exponential function is going to be written in the form of f of x is equal to a times b to the x. That's the exponential functions we've been working with, right? Where a is our initial amount and b is either our growth or our decay, right? Yeah?
Yep.
Okay.
Mm-hmm.
All right.
Yeah.
So on the first one here for part A, what would your function be? Well, your A is your initial amount, so that's
1,500.
1,500. Yeah. And now what about your base?
That's what I was having a hard time with.
Okay. Well, is it growth or is it decay?
Growth.
It's growth.
It's
It
growth.
has to be above a 1.
Yes, right. So what you know is this is the fundamental. You know if it's decay, right? Then what you know is that your base is going to be between 0 and 1. And if it's growth, you know your base is going to be greater than 1. So far, so good?
Yep.
Okay. So how much are we growing by? Well, the growth rate is 15%, right? Which means you're going to grow by more than 100%. That's what the more than 1 means. It's more than 100%. So what would be? It'd be 1.15, wouldn't it? Okay, are you still there?
Confused.
You froze for a second there. I was like, where'd you go? Here, think about it this way for a second. Let's do. Let's see. I'm trying to think of one that's simple. Hang on, let me grab one that's a little simpler from the book. Okay.
Okay.
Let me get one that we can do that's a little simpler here. This is what, 6.2? Is that where we're at, or 6.1? 6.1, right?
6.1.
Okay, all right.
I've actually been doing my homework this week.
Ah, sweet, good for you. All right, here, let's do this. Let's go look at, let me put this one on here for you. This will probably help. Okay, so come on down here, don't get on top of the other one. So this is the worked example from problem 3, okay? So it's very similar to what we're trying to do here. So this is on, if you can't see it so good on the thing, it's on page 207, all right? Okay, so if you take a look and it says, first thing they want you to do is determine whether or not is it growth or decay. So look at the first one here, right? So they want us to determine is this growth or decay? And the model that they're giving us is y is equal to 72 times 1.03 to the t. Okay? All right, so how do we determine whether it's growth or decay? Well, the magic number that we need to determine growth or decay by is that bad boy right there, which is the base, isn't it, right? And what we see is that what? B is greater than 1. And since B is greater than 1, what does that tell you about this model?
That's growth.
Yeah, it's got to be growth, doesn't it? Okay. All right, now they want to know what the growth or decay factor is. That's just fancy wording right here. When they say what's the growth or decay factor, they're just asking you for the base. So you give them the whole number, right? So if you think about it again, it's y is equal to a times b to the x, right? So our a in this particular model is going to be the 72. That's our initial amount. The b, which is the base or the growth factor, that's going to be the 1.03, isn't it? Okay. So now they want to know what is the growth or rate or decay rate. They're asking for it in 2 ways, just to make sure you remember how to work with decimals. They want it as a decimal number and they want it as a percentage, okay? Well, take a look. What was B equal to? Well, B was equal to 1.03. So how much bigger than 1 was it? Well, B minus 1 is going to be equal to what? 0.03?
Yep.
0.03.
Yeah? Okay.
Yeah.
So this number right here, that's the growth rate. So that's how fast you're growing. All right, now what we're doing is we're going the opposite direction over here. So let's come back to the problem we're working. So what they gave us this time is they gave us the growth rate, And so what we got to come up with is the growth factor. We got to come up with the base. And so what's that base going to be? Well, the base is going to be equal to 1 plus 0.15.
0.15?
Yeah. You got it?
Oh, 1.
That's a plus. No, it doesn't look like it. Okay. So the function for this first one here is going to be, I'm going to go with a y instead of an f of x. Okay. Just so it fits in here better. It's going to be equal to 1500 times 1.15 raised to the x. What do you think? Better, worse, or somewhere in between? Well, Kara, what do you think? Is it okay?
Sorry, it's cutting out. Let me.
Okay.
The internet's cutting out.
Okay, don't, that's
I
fine.
probably just have like a blank look on my face this whole time.
This kind of what it does. It just sits there like that, like, it's like, are they listening to me? It's my bad. I should know better. I should know you were just locked up for a second. Okay, so does that make sense though? So the base is 1.15 because we're growth. So you're going to take the growth rate. You're going to add that to 1. All right. So let's go take a look at the K1 down here for an example. All right. So let's get all this work out of the way and let's do a decay one real quick. So in the decay one. So in decay, when we're working with decay, now they're telling us that what we've got is y is equal to 44. That's our initial amount. So there's your A right there, okay? Times 0.92 raised to the t, okay? So our base, our B, that's the 0.92, isn't it? So remember, with the decay one, yeah, the base is between 0 and 1, isn't it? It's less than 1. Well, how much less than 1 is it? Well, 1 minus 0.92 is going to get you what? 0.08? Yeah?
Yep.
Okay, so that's your decay rate, isn't it, right?
Yeah, yeah.
All right. Okay, well, over here, the same song, second verse, it's y is equal to 75. That's our initial amount. But now I got to tell you what the base is. Well, what's the base going to be? Well, it's going to be 1 minus 0.15, isn't it, right?
Yeah.
Yeah? Okay.
Yeah, that makes sense.
All right, cool. So it's going to be equal to what? 0.85, right?
0.85, yep.
Mm-hmm.
So you think you can do the rest of these now?
Yep.
Yeah.
Okay, cool. This one's kind of silly, but you know, whatever. You're going to end up with 2.12 for the base, but that's okay because you're growing by more than 100%, which it's all right. We change. You say you grow by a factor of. It's kind of where the word factor comes in. Okay, we're good with that one. You want to do another one? Charlotte, have you got one you need to do, or what would you like me to do?
No, that was the only one I was stuck on as of last night.
I'm sorry, I didn't quite get that, Charlotte.
I said, no, that was the only one I was stuck on up till last night.
Oh, okay, cool.
I had another one.
You go. Which one would you like?
Number 6 on 6.1.
Okay, and the practice problems?
Yeah.
Okay.
I kind of just skipped it because I didn't know how to do it.
All right, well then let's fix that. Okay, so number 6 in 6.1 from the practice problems, yes? This is the new charter school that opened in 2005 with 300 students. Is that the one we're doing?
Yes.
Okay, cool. This is very similar to that table we just did. All right, so let's go grab the problem. Paste it over here. There we go. All right. Okay, so a new charter school opened in 2005. 300 students are enrolled. Using function notation, write a formula representing the number n of students attending the charter school T years after 2005, assuming that the student population does the following, okay? So what they're looking for from us, what they want for an answer is they want n of t is equal to a times b to the t. So what we've got to figure out is the a and the b. Well, it turns out a is simple because that's always 300. That's not going to change. So it's going to be n of t is equal to 300, which is your initial amount, times b to the t. So it's just like the previous problem. We got to figure out what the growth or decay factor is, or what the base is, and we're going to do that based upon the information that they give us. Okay. Now they're also messing with us because they're not just doing it exponential. I just realized that. Let me back up for a minute. So
yeah, that's what I was having a hard time with.
Yeah. Well, the left-hand side. These guys here, let me do a little color coding for you here, okay? So all of these problems over here, because you see the percentage symbols on them?
Yeah.
Mhm.
Yeah, those are all going to be that model, all right? And so then alternately, these are increasing by a sum or a difference, and so those are going to be n of t is equal to m times t plus b. In other words, they're going to be linear.
Okay.
All right, so all of these guys over here, that's going to be that model, okay? So far, so good?
Mm-hmm.
Yep.
All right, cool. All right, so let's go take a look at part A here. So we'll do A over here because that's the linear one. So decreases by 20 students per year. So actually, let me back up for just a moment because we know the initial amount in this one also, so let's make sure we put that into our model right away. So this is n of t is equal to m, which is our rate, our slope, what do we want to call it, plus 300. Okay, so for part A, we decrease by 20 students per year. So that's going to be n of t is equal to negative 20 t plus 300. In other words, every year you subtract off 20 students. Let's think about it. Let's do a little bit of work with it. So if you did n of 1, that'd be 1 year after the school opened. If you did it 1 year after the school opened, well, how many students are going to be in the school? Well, the 20 less than you started with, so there's going to be equal to 280, isn't there, right?
Yeah.
Yeah.
Okay, and so you know what's n of 2 going to be equal to? Well, that's going to be another 20 students on the way, so it's going to be equal to what? 260, isn't it, right? You
Yeah.
getting it? Okay,
Yeah.
so
Yeah.
after t years, it's going to be equal to what? Take off 20 students per year plus your initial 300 that you started with. Okay, let's go ahead. It decreases by 2% per year. So now we're back over here on this side. We're over into the exponential side. So now what's it going to be? Well, it's going to be n of t, again, is equal to 300. And now, let's see, if I'm dropping by 2% per year, that means that my base is less than 1. I'm decreasing, which means I'm a decay function. So if I'm decreasing and it's decay, then it's going to be what? 0.98, because I'm going down by 2% every year, aren't I?
Yep.
Okay, that's cool? It's good? Okay.
Yeah. Cool.
All right, so n of t is equal to 300. That's 0.9h to the t. Okay, so we increase by 30 students per year. Well, that means every year I add in 30 students, don't I, right? Yeah? What if I did it, I increase by 6%
Yes.
per year? Then it'd be n of t is equal to 300 times 1.06 raised to the t, wasn't it? These are so easy, they're hard once you get the hang of them, right? So I'm going to decrease by 32 students per year. So n of t, so this decrease or increase, recognize that what they're giving you there, that's the slope, that's m. So I'm going to go up by 32 students per year plus my initial 300. And over here in F, I'm going to increase by 30% per year. So that's n of t is equal to my 300 times 1.30 raised to the t. Remains constant, does not change. Well, that would be n of t would be equal to 300, wouldn't it, right? The slope is 0.
Yeah.
Yeah, I got that one right.
Woo!
On E, shouldn't that be negative?
I was like,
Charlotte, I'm sorry, what'd you say?
I said on E, should that be negative 32?
Oh, it's a decrease. My bad. Yes, it should be. Thank you. Grazie. Good catch. Here, let's put that in red.
Okay.
what'd she say?
Oh, I had a positive. It wasn't a increase. It was a decrease. It was decreasing by 32, so that should be a negative 32. I think I said it, but I didn't write it down. So
Yeah.
So increases by 100% each year. So that'd be what? N of t is equal to 300 times 2 to the t, wouldn't it, right?
Yeah.
So if it increases by 100%, then that means it's doubling every year.
You made that look a lot easier. Yeah.
Well, it actually, you think about it, it comes back to this. If you get number 3, right, and number 3 makes sense,
Yeah.
then that should, at least the left-hand column or right-hand column should make sense too. And the left-hand column is just review. You got to remember what we mean by linear versus exponential. Yeah, don't forget about these work exercises. They can be really helpful at times to go back and look at for examples of what the heck they're asking for in a practice problem. Okay, any more?
What'd you say?
Any more? Would you like me to do another one?
I'm looking.
Okay.
I'm looking.
Anticipating. Which ones are going to cause me trouble? There's no other ones that were causing you any issues?
I didn't get as far as Walkera.
Ah. Well, now they won't cause you issues. How about that?
But
I think I was
I
having.
love the calculator. I'm good at it. If it doesn't involve graphing, I'm good at it.
Well, you'll get. You have to say this. I'm getting better at it. Got to give yourself props. Say, I'm getting better at the calculator. I'm getting better.
Actually, I do like the one for the iPhone a lot better than the TI-83.
Yeah.
It's easier
Yes.
to work with.
Yeah. Wakara was in my 380 class, and
Way
we were always,
easier.
yeah, we were always big snobs about, us with our iPhones. We, compared to the poor people who had Android or physical calculators. Okay, so. But,
I got it.
You got it? Okay. So, but Charlotte, I'm going to tell you, I have a Mac, and the Mac talks to the iPhone, and I can actually do screen captures of the Graph and Calc 83. So if you have any issues and you want me to do a demo on the iPhone for you, I can do that, okay?
Oh, okay, cool.
Yeah, so just ask me a question. I can do little videos. I can capture, what it does. Like regression's very different on the iPhone than it is on the regular calculator, but I think it's incredibly easy compared to it.
Yeah, I've been finding a lot of it's easier on the iPhone one than the regular.
Yeah, you push regression and boom, it's done. It gives you everything. It gives you the equation, gives you the graph, gives you the scatter plot. You don't have to do 14 steps like you do on the real calculator. So
yeah.
Okay, so Wakara, which one are we doing?
It's a U-try.
Okay.
From chapter 6.
Okay.
6.2, and its numbers problem 7.
Problem 7 on the U-try. Okay. Problem 7. So writing doubling time. Is a doubling time problem?
Yeah, I had a hard time with the doubling graph
Okay.
for some reason.
All right, let's see if I can get this.
Like graphing it. Because I got the top half okay. I just needed help on like the C part.
Okay. All right. Well, I'm gonna blitz through the whole thing. Okay.
Okay.
So, all right. So after graduating from college in 2010, Sarah accepts a job that pays $52,000 per year at the end of each year. She expects to receive a 3% raise. Okay. So let T represent the number of years Sarah works at a new job. Write the exponential function S of T that models the annual salary given the information above. Okay. So her initial value, her initial salary is the 52,000, right? Her growth rate as a decimal is going to be 3%, so that's 0.03. The growth factor, which is the B value, that's going to be 1.03. That's her base, right? So her salary at time T is going to be equal to her initial value, which is 52,000, times her growth rate, which is 1.03, means her growth factor, sorry, raised to the T. So if her salary continues to increase at the 3% each year, determine how much she will make in 2015. Show your work clearly here. Okay, so they were nice. They gave us, she started 2010, so that's 5 years. So that's S of 5, isn't it? So S of 5 is equal to 52,000, excuse me, times 1.03 to the 5. And I'll let you do the arithmetic that comes out there, okay? So how many years will she have to work before her salary will double what it was in 2010, assuming the same growth rate? Be sure and set up a clearly identified the doubling equation, then draw a sketch of the graph that attained using the intersection method to solve. Be sure and round to the nearest whole year. So doubling equation. All right, so I'm going to come over here. I'm going to show you what I do when I do these to just try and help keep my head straight. So double her salary is going to be $104,000 per year, right? So when she gets to 104,000, she's doubled what she started with. So that means that you're solving the equation. It's 104,000 is equal to 52,000 times 1.03 to the T. And after you've done these for a while, you can skip this step. But at first, to kind of wrap your head around what's going on, I recommend you do this a couple times. So now what I want to do is I want to come in and I want to isolate the 1.03 T by dividing both sides by 52,000. And so if I do that, I divide both sides by 52,000, right? What I see is that the left-hand side turns into a 2, doesn't it? Is that making sense? Yeah?
Yeah, it's making sense.
Okay, cool. All right, so that's your doubling equation right there. Because all you really need to know is when does, think about it this way, when does this thing right here become a 2? In other words, T is equal to what when this whole thing right here is equal to 2? Why? Because that's going to be double my 52,000, isn't it, right? Which is going to give me the 104,000. So what you really want to solve is when does 2 equal the exponential part? So that says 2 equals 1.03 raised to the T power. All right, so now it's time to go get the box out. I'm going to use my fancy schmancy one. I have the color TI, correct?
Yeah, I didn't do that right.
That's okay. So we're going to come in here, we're going to clear this out, and let's put in 2. Doesn't matter what order you put them in. I'm going to put 2 into Y1 and 1.03 raised to the X into Y2. Okay, so, you know, we know a few things about that we can do with the window. We don't need negative time here. We don't care about what she made prior to this job, right? So let's go out, let's just say 20 years. I mean, that's probably going to
Right.
be more than we need, right? And then the Y-min, that can be 0 because we don't have, we're not paying them money to work for them, right? And we know that it's got to go to 104,000. So let's go to 120,000 just so we've got some room to see what's going on, right? And then we'll make the Y scale, you can make that 1,000 or I don't know, make it 10,000, let's say. All right, so if we graph this, see if that worked. I smell a rat. I think I did something wrong here. Oh, my bad. I got rid of all that stuff. I don't need.
It's possessed.
I know. No, it's my brain is possessed. Okay. I don't need to go. I need to go to 4. I need to go to 3 because my Y max is 2. I'm just what I'm thinking here, right? I don't need to go up very high at all because the doubling time means where is the other thing equal to 2? There we go. Hey. It's growing pretty slow, but yeah, looks like it's more than 20 years. She's going to have to work there for a while, okay? So let's go out 30 years and see what she gets. There we go. Okay, so sometime after 30 years, it's going to be in there. So let's go second calc, number 5 for intersect, first curve, second curve, guess. And looks after like about 24 years roughly is when she's going to have double her income. So let's put it in here somewhat like I got it on.
Kind of hard for the for where you have to draw the graph for the window little thing. It's different on the iPhone, so you kind of have to guess.
That's fine. Don't worry about it. Just so you have a rough a rough guess of it. That's okay. But you're going to get the same number though. You're going to get that intersect. That's the important thing, is that you get that you get basically 24 years. It's what 23. They want us to round to the nearest whole year, so they round us. Well, we would round to 23 years basically. Although really it should be 24 because she's not going to make double at that time. So about 23 years.
Okay.
Is that okay?
I just didn't know. I just didn't know because I noticed that my graphs look different than the ones that they give you.
Yeah.
It's supposed to look like.
Yeah. Well, part of it is you got to remember on the screen in the calculator, it's shaped like this, right? Depending upon which way you hold your phone, your screen is either shaped like that or like that, right? So, it depends on which way you want to do it, but it's going to be longer than either of them. Yeah. So don't sweat the window settings so much.
Okay.
Just give me a sketch of what it looked like where you found the intersection point, and we're good to go.
Okay.
All right. Any other ones?
I'm checking.
Okay. So this is the last new material before we take our midterm quiz. So make sure you go and work all of the self-assessments, because the midterm and the final come straight out of the self-assessment quizzes.
I do those.
And there's video solutions. I've done video solutions for all of them too. So if you do one and it doesn't make sense, you can look at the video solution.
What day is the midterm on?
It's all next week.
Okay.
Because it's not proctored, so you get to take it anytime you want next week.
Oh, good.
The final, that one's a little different. That one you got to do in the window of when CR's testing center is open. So it's the 10th week, which is, I forget, July 20th or something like
27.
that. July 27th. Yeah. Okay. So it's like
Yeah.
that week. You got to get it done in that week. And the testing centers are not open on Friday. They're only open Monday through Thursday. So you got to keep that in mind when you're scheduling it.
Are they only during the day also?
Yes. So if that doesn't work for you, then we can do an external proctor. Like if you know somebody who's either a commissioned military officer, a librarian, a school teacher, who's willing to let you come to their house and let it proctored at their house or at their facility, that's fine too. That works.
No, I'll just take off work.
Okay. Whatever's simplest. Make it work, whatever's easiest for you. I have to do a minimum of one authenticated assessment. So that's the one we're doing.
So you put on one of my grades that I didn't scan one of my problems in. My phone is not liking scanning sometimes. I don't know if it's because the angle of the book. So I try to get those in before they're done. So.
Well, Charlotte, if anything like that, any sort of technical difficulties you have, you get it in and I put a comment like that, you can always resubmit it to me through a message saying, oh my God, I missed that one page or whatever, and send that to me and I'll go back and regrade it for you, okay?
Okay.
I don't want to penalize you because of technical difficulties. So if you have an issue like that, we can always fix it.
Okay. Because I'm trying to do it on my phone and I should just pull it up and do it on my iPad, but I don't always have that charged.
Ah, okay. Yeah, whatever works for you. I've got probably about 5 people who are just bringing the book up and just writing it on the book on the PDF and submitting that saved PDF. And that works great for a lot of people. Particularly folks who have like iPads or have, Microsoft Surfaces or, those touchscreen type devices. That works out pretty well.
Yeah, it's horrible with just a mouse.
Oh my God, no, don't do it with a mouse. Well,
I did it like that for like the first day.
Yeah, I have this right here I think this cost me $20 delivered from Amazon with a stylus and a pen pad. And this thing rocks. I had a big old huge Wacom graphics tablet that the department owned and I gave it back. I said, I like my little X Pen cheapo thing way better. It's much simpler to deal with. So, yeah, but yeah, don't.
Did you say it was an X Pen?
Yeah, it's here. It's XP Pen. I think. Can you see it?
Yeah, I'll check that out.
Yeah, go take a look at Amazon. They were super cheap. People buy them, I guess, for playing games online.
Well, I was thinking about using it for work when I'm taking notes too.
Yeah, you can scribble right in the book. You can do all sorts of stuff.
Yeah.
Yeah. At one point when I was developing this class, I almost was toying with it, making everybody get one of those and doing their work in the book. But for some people, that would be a major hardship. So I decided, no, we'll stick with it.
For that price, it's cheaper than these $200 books. So you can get the book and that.
Oh, I know. That's why I'm doing this book. These people are amazing. The people out of Arizona. I contacted Miss Gaudet, who's Goddard, however you say her name. She's the one who's in the videos.
Yeah.
And I asked her, I said, hey, I want to make this book available to my students. How do you guys get paper copies? And they go, oh, well, we're out of Scottsdale. We just have a local printing company that we use. And I go, well, can I put it up on Lulu? Would you mind if I did that? She goes, yeah, sure. Go ahead. You can do that. But I'll get you a hold of the Scottsdale people and let's see what they can do for you. So I put it up on Lulu and I sent her the link and said, well, I can get it for $8 a student, $12 delivered. And she went, what? I guess their local printer had been charging like 20 or 30. So she was like, thanks for the tip. So
yeah, it was well worth it. One of my, the people that worked under me at the office just bought the business law and it was $130 some odd dollars.
Yeah, not that actually is the scary thing about it. That almost seems reasonable compared to some classes, where they charge you $250 for a textbook. It's just, yeah, it's insane. No, one of my goals when I built this class was to make the cost as minimal as possible. So that's why I let people use the app on their phone. why we're doing the group activities using Desmos. There's all sorts of packages I could buy from publishing houses to have you guys doing group activities and stuff like that. But I wouldn't buy. You'd end up paying for it. So it could cost you hundreds of dollars for not very good stuff. So anyway, enough of that. Let's talk about more math. You guys got anything else you want to do, or I'm going to go eat dinner because I haven't eaten dinner yet.
Well, that's it for me because I'm going to go eat dinner too.
My last problem.
You give it to me, okay. Which one are we doing?
Just one last problem.
You got it, girl. Bring it on. Which one?
Okay, number 9.
Number 9?
Number 9 on 5.4 practice problem.
5.4 practice problems, number 9. All right, we can do this.
And it's just the C and D that I was having a hard time with.
Okay, let's take a look.
Because it is kind of long.
Yeah. Is it one of those ones where it's like 85? Yep, number 9. Okay, here we go. Yeah, I can't even read these names. All right, so this is the rabbit population, right? Is that the one?
Yeah.
I said I didn't care how many rabbits were there.
Whisk away wabbits. All right, let me get this.
I was doing that one at work. They were laughing at me.
All right, I'm going to have to do this one in 2 pieces here. Okay, so there's the first parts of it. Let's see. Okay, good. It ends on the second page. And then here's the second part. All right. Okay. All right. Let's go back here. All right. So the rabbit population of several counties is shown in the following table. Assume the growth is exponential. Let t equals 0 represent the year since 2006. Let A represent the initial number of bunnies in 2006, and let B represent the ratio in population between 2006 and 2007. So write the equation, the exponential mathematical model for each situation. Round any decimals to 2 places. Be sure your final results use proper function notation. C for coquina, Y for Yayape, I think it is, and H for Harshdue. So these are all counties in Arizona. I recognize some of the names.
Of course, they have to be hard names.
I know, right, exactly. Okay, so let's see. So let's go. So you guys do a little bit of this with me. So we know C of T. We're going to go 2006 is our initial population. So in each of these cases, remember that that's going to be A for this model.
Initial.
Yeah, exactly. That's going to be A for this model, and that's going to be A for this model, okay? So we've got 15,000. And now what we need to do is we need to get what our growth rate is going to be raised to the t. And what they say is to figure out your growth rate is to go ahead and take it between 2006 and 2007 and just assume that that rate stays constant. So for C, for, coquina or coconino, we would take, what, 18,000 divided by 15,000, right?
Yeah.
And so that's what your growth rate B is going to be equal to. So what's that come out
I think
to
it's
be?
1.2.
1.2.
1.2.
Okay, cool. Sweet. All right. So for Yavapai, so Y of T is going to be equal to 8,000. And we're going to take for Yavapai or Yavapai, going to take 128 or 12,800 and divide that by 8,000. And so what would that come out to be?
1.6.
1.6. Okay.
1.6.
Yeah, rabbits are having more fun in that county. Okay, and then for hare stew, I think they made that one up. The hare stew county, yeah. Where's my Hufflepuff?
That's horrible. That's horrible.
What's even worse is that one's decaying.
It's decaying, yeah. It's because it's hare stew county. Because everybody's eating the rabbits. And so that's 18750.
This just got really dark.
Yeah, exactly. Kill the rabbit, kill the rabbit. All right. So what did that turn out to be? What was H?
0.75.
0.75?
0.75.
Okay.
Yeah.
Yeah, so they started off with a lot of rabbits, but it's dropping quickly, right? 25% per year are going away. Okay, so those are your models. So using the models in Part A, forecast the rabbit population in 2012 for each county, round to the nearest rabbit, use proper function notation to represent each result. So 2012 would be what? That's going to be 6 years into the future, right? So you're going to do C of 6, you're going to do H of 6, and you're going to do Y of 6, right? So we've got to figure out each one of those. So that's going to be 15000 times 1.2 raised to the 6, and then this is going to be 8,000 times 1.6 raised to the 6, and then it's that times 0.75 to the 6. Okay, so can I let you guys do the calculator work on that for me?
Yep.
I'm just going to go ahead and say good enough. I know you guys can do
Yeah.
that part. Okay, so let's go to the next page. All right, so use the modeling for each of the following show complete work. The rabbit population, when does it reach 60,000? So we've got to take 60,000, and that's going to be equal to
15,000
yeah, I'm going to get back around.
times 1.2.
Yes. 15,000 times 1.2 raised to the t power. So the question is the time. So we got to solve for the time. Now for this chapter, and for chapters 5 and 6, we're doing it graphically. Chapter 7, we're going to learn an algebraic technique for doing that, but we don't have that tool yet. That's in the next chapter. So it's up to you how you want to do it. You can load this thing in just like it looks, or you can do like we did with the doubling time problem, and you can divide out that 15,000 to make your numbers a heck of a lot easier to deal with. And so what happens, what's 60 divided by 15? What's that get you? Give me something, where are you? Where'd my calculator go? Okay, so
4.
is it 4? I believe you, but I'm going to do it anyway. Okay, so what that means is you can make your life a lot easier. It's going to be 4 is equal to 1.2 to the t. So you're going to say y1 is equal to 4, y2 is equal to 1.2 to the t. Can I let you take it from there, Wakara? Does that make sense?
Yeah, that makes sense.
Okay. So load those in. Again, touch the point of intersection, you're good to go. Okay, so for y of t, got 340,000 wabbits is equal to, see, what was the initial on that one?
1.6 is the
growth rate, so it's
Yavapai.
Yavapai, yes. So it's 8,000 and 1.6, right?
Yep.
Okay, so same trick. Come in here and divide out the 8,000 from both sides.
42.5.
42.5? Okay. So 42.5 is equal to 1.6 to the t. That's going to be a heck of a lot easier to do in the calculator than putting in 340,000 and 8,000 and trying to find the point of intersection that way. So rabbit population in Hairstew falls below 5,000, okay? The natives are getting hungry.
25,000.
Is it 25,000? Okay.
Yeah.
25,000.
Times 0.73.
73? Is that what it was?
0.73.
0.73. Okay. I think I had 0.75 on the previous screen.
7.5 is what I had.
7.5. Sorry.
Yeah. Okay. Good. All right. So it is 7.5. All right. I'll make sure I get the right number there. Okay. Cool. All right. So same thing. Divide out 25,000 from both sides. And if you do that, what do you end up with?
0.2.
0.2. Okay. So 0.2 is equal to 0.75 t. So which of the following scenarios in part C happened first? Explain your reasoning. So all they're asking you for here is which of these t is the smallest. So in other words, which population got to the value they were asking you for first? Does that make sense? So in other words, you got to find out what the 3 t's are. So you're going to know, you're going to get a value of t up here, you're going to get a value of t here, and you're going to get a value of t here. So you're going to have 3 different values of t, and they're going to ask you, which one of those is smallest. Smallest being that population got there first, okay? And then explain to them why.
Okay.
And it should have something to do with that B, with that growth rate. I mean, I'm suspecting, let's see, yeah, probably, you guys probably haven't done it yet, but Yavapai probably got there pretty fast because 1.6 for a base is pretty big. But I'll let you chew on that. I'll let you chew on that one and see what it is, okay?
Okay.
All right. My stomach's growling, and it's 9:06.
All right.
Okay.
So that's a wrap. So this will be up if you forget something and you want to look at it again, you can by tomorrow morning it'll be posted up in the archive. Okay, so you can take a look at it there too.
Mm-hmm.
All righty then. You guys have a great rest of the week and a great weekend.
Thank you.
Bye.
You too.
Bye bye.
You too. Thank you.